C-O-N-I-C. And the root word of the word conic is cone. And we'll talk a little bit more about this tomorrow. But we're moving on to Chapter 10, and we're going to learn about what we call in mathematics conic sections. All right. Conic sections have 4 graphs that we're going to study. One of those graphs we've already studied, and it's the circle. So just to give you just a really quick overview of Chapter 10, and we know that the circle was not in Chapter 10, it was in Section 2.8. Not sure why they put it in 2.8, but they did. So one of the conic sections is called the circle. We have another graph that we call one of the conic sections, and it's called an ellipse. And an ellipse is like an oval. That would be another way to describe it, okay? An ellipse is an oval. That's what we're going to take notes on today. A lot of times people call an ellipse an eclipse because we're kind of a little bit more familiar with what an eclipse is. But it doesn't have a C in it. It's 2 L's, E-L-L-I-S-P-E, ellipse. I spelled that wrong. P-S-E, sorry. Did I even say it right? Who knows, right? Ellipse, okay. The third one, the third conic section is called a hyperbola. That sounds like something that you know about in English. But a hyperbola is actually 2 parabolas all in one graph. Some people call this a hyperbola, but it's pronounced hyperbola. I don't care what you call it, as long as you can identify it in the end. And then the last conic section is actually a parabola, and we've already studied the parabola, but the parabola that we studied either went up or down. So we're going to review parabolas that go up or down, and we're also going to talk about parabolas that go to the right or to the left. So we're going to add to our knowledge about what we already know about parabolas, but we'll study about parabolas going in 4 different directions. So conic sections, when you hear about conic sections in mathematics, we're talking about 4 different graphs. The circle, the ellipse, the hyperbola, and the parabola. Okay? We've already studied the circle. We'll review that a little bit later on. Today we're going to talk about the ellipse. The next day we're going to talk about the hyperbola. The next day we're going to talk about the parabola. The following day we'll mix all these graphs up. We'll talk about all 4 of them mixed up, and then we'll have one big test. We haven't had a test that counted twice in a while since the Chapter P test, but we will have a test on this chapter, on Chapter 10, on the conic section. So it's 4 graphs: circle, ellipse, hyperbola, and parabola. All right, if you'll go back to the top of your notes, these notes are already filled out for you. I knew that we would not have a lot of time, but they are already filled out for you. So let's just kind of look at them together. It says the standard form for an ellipse. There's 2 different types of an ellipse. There's an ellipse that we call horizontal. That means it's longer left and right than it is up and down. So we have an ellipse that's horizontal, and we have an ellipse that's vertical. I'm not going to make you name, hey, this is a horizontal ellipse and this is a vertical ellipse. I just want you to kind of be familiar with that vocabulary. Now, if you'll notice, part of the standard form for an ellipse looks a lot like the circle. Y'all see the x minus h squared and the y minus k squared? That's exactly the same as a circle. An ellipse is actually going to have some numbers in the denominator, and those numbers are going to be a squared and b squared. Also, the standard form for an ellipse is always going to equal the number 1. So the difference between the equation for an ellipse and a circle is always going to be equal to the radius squared. Okay? And an ellipse is always going to be equal to 1. And also another difference is an ellipse is going to have some numbers in the denominator, like these a squareds and b squareds. The circle is found exactly the same way by doing h comma k. And then let's just jump right in and show you how to graph these. Again, they're already graphed, but I'll walk through the problems with you. So in number 2, you see that x squared plus y squared? There's no binomial squareds. That means your center of your ellipse is at 0, 0. You're going to look at the first denominator. That first denominator is 25. You're going to take the square root of 25, which is 5. And since the 25 is underneath your x squared, once you take the square root of it, that's going to tell you to move left and right. Whatever is underneath your x, once you take the square root, you move left and right. Then you take the square root of 16, which is 4. You're going to move 4 units up and down. You're moving up and down because your 16 is underneath your y. Okay? You plot your center. You go left 5, make a point, right 5, make a point, up 4, make a point, down 4, make a point. You sketch that in. This ellipse is really, really, really close to being a circle, but it's not because it's not the same distance from the center in every single direction. Okay, would we call this a horizontal ellipse or a vertical ellipse? It's a little bit longer horizontally. It's kind of hard to tell. All right, look at number 8. You don't have a binomial squared for your x squared and your y squared, so your center of your ellipse is at 0, 0. The square root of 9 over 4 is what? 3 over 2. The square root of 25 over 4 is 5 halves. So you plot the center of your ellipse. You go to the left 1 half, or 3 halves, which is 1 1/2, to the right 1 1/2, up 2 1/2, and down 2 1/2. We know we're going left and right 3 halves because the 9/4 was underneath your x. We know we're going up and down 5 halves because the 25/4 was underneath the y. Okay? Some of your equations are not in standard form. So if you'll notice, if we look at this very first problem, I know that it's not in standard form because it is equal to 36. And an ellipse equation is not equal to 36. An ellipse's equation is always equal to 1. So really easy fix here. If you have equals 36, guess what you can divide by? Divide everything by 36. Do y'all see how we're getting x squared over 4 plus y squared over 9 equals 1? Okay, so since you just have an x squared and a y squared, no binomial squareds, that means your center is at 0, 0. The square root of 4 is 2. You're moving left and right 2. The square root of 9 is 3. You're moving up and down 3. Graph the center, move in the directions that you've marked. Okay, 18 is a little bit more out of standard form. I have my x squared on my left, but I have that negative y squared on the right. You don't want your x squared on one side and your y squared on the other. So the first thing that I'm going to do there is I'm going to move that negative 5y squared back over to the left-hand side. Now the equation is equal to 30. Ellipses standard forms are not equal to 30. They're always equal to 1. Divide everything by 30. That gives you x squared over 5, y squared over 6 equals 1. The square root of 5 is about 2.2. The square root of 6 is about 2.4. Just round your decimals to the 10th. Sketch your center. Move the directions that you're supposed to move. Okay, any questions before we look at some whose centers are not at 0, 0? All right, number 20 says, given the graph, find the standard form of the ellipse. So they're giving you the graph. You're going to visually locate the center of that graph. You're going to visually locate the center. The center is at 0, 0. So that's going to be your H and your K. And then you go left, what is that? 4, right 4 from the center, up 2 and down 2, and then you write the equation, x squared over 16. Where does 16 come from? 4 squared. Then plus y squared over 4, because you moved up and down 2. You'll have to square the 2 to put the denominator back in, equals 1. So you may have a few where they've graphed the ellipse for you, and then you have to come up with the equation. Now the next example does not have a center at 0, 0, so you'll figure out where the center is just by looking at your graph. The center there is -1, -1. And then you'll use that center to write the top part of your equation. If your center's at -1, -1, then your binomials are x plus 1 squared and y plus 1 squared. When you put those numbers, the h and the k, back into the equations, you change their signs. All right, we move left and right 1, so 1 squared is 1, 1 goes under your x. You move up and down 2, 2 squared is 4, 4 goes underneath your y. All right, 38. Does everybody get why the center of the ellipse is 1, -2? Okay, same as a circle. 1, -2, square root of 16 is 4, left and right 4, square root of 9 is 3, up and down 3, sketch your ellipse. This is just an ellipse that does not have a center at 0, 0. So 38 is already in standard form. It's already set equal to 1. It's got those little nice denominators, so you're just ready to find the center and figure out how far you're going to move left and right, up and down. All right, last few examples are not in standard form. What are we doing in the first step in number 50? Dividing everything by 36. Dividing everything by 36, and then you get your ellipse in standard form. All right, 52, this will be the last one that we look at. 52 is way out of standard form, okay? We've dealt with this with a circle, okay? So we're going to use some of the same things, and we'll pull this up so we can look at 52. So the first thing that I'm doing in 52 is I'm getting my x's together. So if you'll notice on that very first line, I'm rearranging my terms. 4x squared minus 32x, and then I have the 9y squared plus the 36y, and then I said red rubber, send the constant right over, okay? Let's look at this line right here. Let me bubble it up where y'all can see. What are we doing in this step right here? Okay, we're factoring out the number in front of the x squared, which is 4, and then we're going to factor out the number in front of the y squared, which is 9. We have to do that because we can't complete the square if there's a number in front of the x squared and the y squared term other than a 1. In the next step, we are completing the square. 8 divided by 2 is 4. 4 squared is 16. Then over here I'm doing 4 divided by 2 is 2. 2 squared is 4. So I'm adding the 16 and I'm adding the 4. So I'm doing the complete the square there. Now let's go over here to the right hand side. I added a 64 and a 36. The 16 that I added, guys, is being multiplied times 4. I added a 16, but the 16 was inside the parentheses and that 4 is on the outside, so I really added 64 when I added the 16 because it's being multiplied by 4. So you have to add 64 on the right. Then when I added the 4, it was being multiplied by 9, so I really didn't add 4. I added 9 times 4, so I added 36, so I had to add the 36 on the right hand side. Then your trinomials factor into binomial squareds in the next step, and then your equation equals 36, and it's supposed to equal 1, so you're going to divide everything by 36, and the equation simplifies down to its standard form. 52 is as difficult as they get. They won't all be as hard as 52, but that will be something that I will ask you to do that's the most difficult. All right, we will cover one section a day.